Hi everyone. So now what I'm going to do is I'm going to use the symmetry of the circle to help with solving some more complex problems. You might remember in the past you would have seen something like this. So talking about the four quadrants of the circle, quadrant 1, quadrant 2, quadrant 3 and quadrant 4. In quadrant 1 all of sine, cos and tan are positive. In the second quadrant only sine is positive. Now remember that this is because sine is the y value. We can see here that the y value is above the x-axis, which makes it positive. In quadrant 3 only tan is positive. Okay, so that's because we trace back across the circle until we hit that tangent line. And in quadrant 4 only cos is positive. So cos being the x value, we can see the x value is positive out there. Okay, so ASTC, you might have a way of remembering that. It's a good idea to make up some kind of acronym that you can help to remember that. But we're going to be using that today. So in the first problem, we're doing sine of 5 pi on 3. To start off with, it's actually a good idea to just draw a quick sketch of it so we can get some idea of where it is and what it is that we're dealing with. So 5 pi over 3. Now that's obviously broken into units, a multiple of pi over 3. So if I count by pi over 3, so I can go pi over 3, 2 pi over 3, there's 3 pi over 3, which is just pi. Then 4 pi over 3, 5 pi over 3 is going to be down here somewhere. So I might just draw a quick sketch going out there. So the angle that I've turned through there is 5 pi on 3. And we can see down there, that's the fourth quadrant, only cos is positive. We're dealing with sine, so it's going to be a negative answer. Okay, the y value is negative. So I also said that it was a multiple of pi over 3, and we can see that the other part which is remaining in here is going to be pi over 3. So what I can say is that sine of 5 pi on 3 is equal to sine of 2 pi minus pi on 3, because that is absolutely true, but that's actually equivalent to negative sine of pi on 3. So it's like if I were to take the angle of pi on 3, I would get the same sine value, the same y value, but it's actually reflected so that it's down here in the fourth quadrant. Okay, so that's all that's happened there. We're just using the symmetry of the circle. And from the table of exact values, we know that sine of pi over 3 is going to be just thought I'd test you out and let you see if you could actually figure that one out. So sine of pi over 3 is going to be root 3 on 2. So this is actually just negative root 3 on 2. Done. So the next one, tan of 5 pi on 6, again, draw that quick little sketch just so we can see what's going on. Okay, it's broken up into multiples of pi on 6. Now, pi on 6 is only 30 degrees. So that's pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6 is out here somewhere. So that's the angle right there, 5 pi on 6. And we can see that's in the second quadrant. Again, tan is unfortunately going to be negative in this case. And the angle which is left over there is just pi on 6. So I can say that tan of 5 pi on 6 is equal to tan of pi minus pi on 6. And because I know that tan is negative there, I can instead just say that that is negative tan of pi on 6. Okay, that same basic angle is going to give us the same tan value, it's just negative. And so when I do this calculation, tan of pi on 6 is 1 over root 3, and so we end up with negative 1 over root 3. Now there's only about 15 seconds left, so I'll save the last example for the next video.